So this is processing. Chosen the wrong pen anyway. Processing two jobs. Processing two jobs. Two jobs on M machines. M machines. Okay. So today I'm going to this problem. That is processing of two jobs on N machines, M machines. Okay, we have only two jobs, and you have multiple number of machines. So far, I have covered two jobs, two machines, N jobs, three machines, N jobs. But now it's a typical problem where you have only two jobs and you have number of machines or more here. So take the problem now. Audible now. I'm audible. I'm audible. Yeah. Okay. Yeah.
Yes, sir. Yes, sir.
Yeah, you please take the problem now. Using graphical method, determine the optimum sequence. Determine the optimum sequence needed to process two jobs. Process two jobs on five machines. Determine the optimum sequence needed to process two jobs on five machines A, B, C, D, and E. So you have five machines A, B, C, D, E, and only two jobs. Now, for each machine, find the job which should be done first. So you have to find out which job is going to be processed on machine. For example, job 1 on A, job 2 on B, job 1 on C. Likewise, you have to find out the sequence. For each machine, find the job which should be done first. And also calculate the total time required to complete both the jobs. So you have to find out two things here. It is sequencing of jobs. Which job is going to be done on which machine? Okay. And also you have to find out the total time required to complete both the jobs. Now you have two jobs, job 1 and job 2. So for job 1, you have here sequence A, B, C, D, E. Is a sequence given in the problem. For job 1, you have the sequence given in the problem, that is A first, then B, then C, then D, and E. These are the sequence. And the processing time in hours, it is for machine A, it takes 1 hour, machine B takes 2 hours, C takes 3 hours, D takes 5 hours, and E takes 1 hour. So these are the processing time on each machines A, B, C, D, E for job 1. Similarly, you take job 2. Job 2 also you have the sequence. That is in the sequence of C, A, D, E, B. The sequence given for job 2. Job 2 should be processed in this sequence only. You have five machines. The sequence of processing is first should be done on C, then second should be done on A, then on D, then on E, then on B. Likewise, it has to process on in the sequence only. And the time required to process on each machine, that is the time in hours given, that is the C machine requires 3 hours, A4, D2, E1, and B5. So this is the problem given. You have to find out the sequence of jobs to be done on machines and also the total time required to complete both the jobs. So this question is for 12 marks usually, 10 to 12 marks, because this unit, it's a combined unit having waiting theory, queuing theory or waiting theory, queuing theory along with sequencing. So sequencing 12 marks, 8 marks you're going to get queuing theory problems. Okay. Done? Have taken? Shall we go for solving now? Have taken the problem?
Yes,
Anyone
sir.
can answer me? Shall I go ahead now?
Yes, sir.
For solving? Yes. Okay. just I'm learning, so it may take some time for me to adjust with this clear canvas. Okay, yes, we'll take one blue black pen now. Okay, let's start doing here. Yes, see now I'm going to solve this problem now. Okay. Okay, see here, you just check out the total time required. For job 1, it is 1 plus 2, 3 plus 3, 6, 6 plus 5, 11 plus 12, 1, 12. Whereas for job 2, the total number time taken is 4 plus 3, 7, 9, 10, 15. So you draw a graph of 15 each. Okay, so draw a line. And you have to mark job 2 here and job 1 here. Okay, just mark it, and just because I told that total is 15, just make a box of 15 now. Okay, so you write here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Similarly, you also mark here. It is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So mark here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. You mark all these things. Okay, and now, okay, so you have the given sequence. Say for example, for job 1, the sequence given is A. So now what to do now here, it is from here to here, you mark A job, is A job, because so job 1 I'm taking now, job 1 sequence given is A, B, C, D. You mark job 1 takes 1 hour. Job 2, sorry, mission B takes 2 hours. It is 1 plus 2, 3. So mark here B. That is second sequence. Third sequence C, it takes 3. So that is 3 plus 3, 6. So you can mark here C up to 6. Next, D, 5. That is 6 plus 5, 11. So up to here. So mark here D. Next, D, E, 12. E1 is 12 is there. Okay, 12. Okay, so this is E. Okay, 12. Similarly, you mark here also. It is a sequence given is it is a CADEB. Okay, so CADEB C3. Okay, so from here to here, you mark this as C now. C. Okay, C. Second, A, 4. So 3 plus 4, 7. So you mark here A. That is 3 plus 4, 7. Next, D2. 7 plus 2, 9. So you mark here D. 2 hours. Similarly, E1. That is 10. So you mark here E. Takes only 1. And similarly, B5, that is 10 plus 1, 5. So up to here, you're going to get the B. Because 10 plus 5, 15. Okay. Now here from 15, 15 to just make a box here like this. Okay. So from here also you have got 12, right? So you have 12 here. Okay, make a box like this. Okay, that is 15 from here and from here to here, and you have maximum 12 is there only 12. Okay, so just to make a box of this one. B job take so 12, 15, whereas job one takes 12 only. Okay, you mark according to the sequence given sequence. So C A D E B is the sequence for job 2. A B C D E is the sequence for job 1. Okay, have marked this one first. Have marked. Have marked.
Yes, sir.
Yeah, so very simple. You have a graph that's just only mark the sequence, given order A, B, C, D, E for job 1, job 2, C, A, D, B along with the one. Now, you just say, for example, you take machine A first, machine A is here, okay, machine A is here. So, machine A, how much it is? 3 to 7, right? No, 3 to 7, 3 to 7. So, here 3 to 7 is there. And similarly here you have A. So just mark here. So this is, that is A. Okay, and mark these things with the line. Okay, just mark it here. This A for job 2 it takes a 4 and here. So A is here and here A. So the B now. B is here and B is here. Now from here, okay, where is B here? B is here. It is a 10. Okay, so from here to here plus B here is from here to here. So it is up to 3. So here B, mark B now. Okay, mark B. Okay, next similarly C. C is here, C is here and here. So from here to here, so from this point it starts and from here to here, it is C. Corresponding places only what to mark C. And D is here, whereas D is here. So from here it starts, D to here it starts. So you have 3, 4, D here. D. And lastly, E is there. So E is here and E is here. E. Request you mark all the boxes. Okay. A corresponded this A and here A. And B here and here, C from here and here, D here and here, whereas E comes here and from this point E. Likewise, you have to mark. Okay, mark all the boxes very perfectly. Don't draw like this because I am not getting exact here. So because I am drawing a bit difficultly, I am drawing. Okay. Have you drawn the boxes now? Have you drawn the boxes?
Yes, sir.
Okay. Now here, remember, you have to draw a 45-degree line. 45-degree line. Okay, line from 0 to this point. This point means from here to here, you have to mark 45-degree line here. So we want to draw 45-degree line. Okay, line means both jobs are processing. Suppose you're going to say that you're going to draw 45-degree line here, then meaning that both jobs are processing. Okay, if it is 45-degree line, done. Okay. For example, if there is, for example, here, when line is going to come like this meaning that here it is job 1 idle. Job 1 become idle. Suppose you're going to draw a line like this. That is, you can say it job 2 is idle. I will show you how exactly. Okay, so what I'm going to do here now is here. So you draw a line here. You draw a line. What would a line here? Sorry. Actually, it comes like this. You draw a line. I think up to come up to here. Check out. You draw a line like this.
Sir, if we draw the 45-degree line, it will not meet that corner, right?
Yeah. It won't meet. That's what you draw up to here only. Okay, draw up to here only.
Okay.
Now up to here it comes 45 degree. If you want to draw a line up to here, it comes. It may come up to here, right? No. To draw lines, you come up to here.
Yes, sir. Yes.
Okay. See, for example, here, if you want to draw up to here, then you have to come like this. Then you have to draw once again a 45 line here. Then you have to go here. So what you do is you have to make sure that jobs are going you make sure that both jobs are going to be simultaneously. So you have to make sure that you should get lesser straight lines. So what I'm going to do here, I'm going to draw up to here line like this. Okay, I'm going to draw a line like this here. Sorry, I don't know how to do undo.
Sir, press Control Z.
Press Control?
Control Z, sir.
Z?
Yes, sir.
Okay. So thank you. Okay. See now, see up to here it comes. See, for example, the basic idea is what you have to draw a line up to here. Okay, so you can't draw. If you want to draw a line here up to here, then you have to draw up to here. Then once again you have to draw here. Then once again you have to come here. Then you have to draw vertical. So in that case, what happens here? You are going to get more of horizontal line, meaning that dispatch of our job to become idle. Meantime, what you want to do, draw up to here means you are going to get job 1 also become idle. So what I'm doing here, that I'm going to draw directly here. So what I'm going to do here, I'm going to draw a line like this here. Okay. So from here, I'm going to draw a line up to here. And then I'm going to draw a line here. From here, of course, this point is supposed to meet here, of course. In fact, these two are going to meet, in fact, as per the graph, you're going to draw like this. Okay, anyway, it can, from here, you can draw once again a 45 line here, from here. So from here, if you're going to draw a line, okay, so I think it should draw 45 line only, okay, from here. So here, from here, if you're going to draw a line, you're going to get like this. Okay, that's how you're going to get. Check out here, you check out your graph, because don't say for my graph, because a little bit this thing is there, okay. Okay, now you get like this, huh? Like this. right?
Yes, sir. Got it, sir.
Yeah, you got it, no? Okay. Now, check out here. So, what is the total elapsed time? Total elapsed time, check out here. Right, elapsed time for job 1. I'm going to write here. Okay. Okay. So now here, say, you have to find out the total elapsed time. Total elapsed time. Right. So for job 1, here job 1 you have totally 12 hours. Right, time equal to 12 hours. Okay, 12 hours. You check out whether job 1 is anytime idle. Okay, so job 1 is idle now. Here from here to here, it is totally 3 hours become the idle time for job 1. Okay, job 1. So here from here you draw a line like this, and you're going to get it's a 3 hour idle time for job 1. So plus 3 hours. Okay, it's idle time. Okay, is equals to totally 15 hours. 15 hours for a job 1. So this is the idle time. This is very important. This idle time should be calculated totally. Similarly, job 2 now. Job 2. So actually it is 15 hours totally. That is add all these things. So totally you're going to get 15 hours. 15 hours. Plus check out you have any horizontal lines are there. No lines here, horizontal lines here. So it means that you don't have any idle time for job 2. So it is going to be 15 hours only for job 2 also. Okay, that's how you're finding the total elapsed time. So job 1, 12 hours is the total time. Because this is a vertical line become the idle time for job 1. So 3 hours is a straight line. So idle time 12 plus 3, 15 hours. And for job 2, there is no horizontal line here. So totally 15 hours. So they are the total elapsed time. Okay. Anybody got doubt here? Anybody got doubt? Understood now?
Yes, sir.
Yes, sir.
Yeah. Now I am going to tell you that the after sequence. Now you write down the optimal schedule now. Optimal schedule. I'll tell you how to draw schedule corresponding to the chosen path. Corresponding to the chosen path. Right here, I think you understand afterwards. So you have job 1, and let us say I'm going to draw one bar chart here, So total processing time is 15 hours. You have to adjust this on lines, okay, time being. So now you mark here first A, that is 1 hour, that is 1. Next, that is 1. Sequence only, yes, as per the graph you are drawn. Next, B, that is B, 3. Next, C, it is 6. 4, 5, 6. Next, 6 to 6. Okay. Next, here, what happens here? 6 to 9. So there is a idle time as per the graph. You can check out the graph. Idle time is there. 6 to 9. The graph is down vertically. Next, 9 to 14, 16. It is 9 to 14. It is a D. 16. Sorry, 16 or 14. 14. So it is D. And next it is E, so it's 1, total 15 hours. Similarly, you would draw for job 2 also. Job 2, draw once again a bar chart for all 15 up to 15 here. Just after both should be same, right? So first sequence C, it is a 3 hours. 3. It is a 0. 3. Next A, it is a 4, so 7. So here A, 7. Next D, C A D, D how much? 1. I think D how much? It's 2, means 7 to 9. So D, 9. Next, after D, you have E1, that is a 10. That is E, 10. And lastly, B, I think. Yeah, B, 15. B, so totally 15. So this is a bar chart indicating the total processing time, that is including the idle time you have shown here. Okay. Now you have to find out the optimal sequence by seeing the bar chart. Say now you have machine A. Tell me now which job to be taken here for machine A. Job 1 or job 2? Machine A. Job 1 first. Right now, because immediately from 0 only it takes. Okay, so job 1 precedes job 2. Precedes job 2. See, check out in graph. See, job 1 starts immediately. It is 0 to 1 only. So now for machine B, machine B. Tell me which job machine B. As per the graph, machine B, job 1 only. Okay, see, because immediately as per sequence, so job 1 only take job 1 precedes job 2. Next, similarly, machine C now. Machine C, which job takes machine C? Here, job 2. Job 2 precedes job 1. Similarly, for machine D, okay, machine D, check out which job takes first? Job 2. Job 2 precedes job 1. Machine next E. So here also job 2 precedes. Job 2 precedes job 1. Okay. So that's all about the optimal sequence. Check out that which job you going to done on which machine. Okay. See in the graph, check out here. So job 1 on machine A, it's going to be 0 to 1 only. That's why we have taken job 1 first on machine A. Similarly, job 1 on machine 2, because after 1 hour it takes. So, but whereas in case of C machine, it is job 1 starts after 3 hours, whereas job 2 starts immediately. That's why you take job 2 for machine C. Job D, say for example, job D. So job D takes from as per the so here It takes after 9 hours, after 9, because the 3 hours idle. Even though in the graph it is shown 6, but you have to add 3 hours idle time here. 3 hours idle time here. So job D can be taken here only after 9 hours. Whereas job 2 can be taken immediately after 7. That's why you can say job 2 first in D. And E also. See here it takes after 14, but here it can be taken after 9 only. That's why job 2 first. Okay. Likewise, you have to draw the upper sequence. Understood now? I hope you understood. Very easy. To solve some more problems to understand it. Okay now? Hello?
Yes, sir.
Okay, yeah, that's all. This is the simplest problem in fact. Only you are drawing the graph and drawing the 45 degree line very importantly. Okay, make sure that you are going to make very less idle time, and immediately you have to draw the optimal schedule corresponding to the chosen path. That is, you draw the a bar chart like this for a given this thing. But very importantly, you have to mark the idle time so that based upon this time only you can draw the optimal sequence. Okay. So that's all now. First problem. I will take up one more problem for you people so you can understand it. Understand better. Two jobs. Processing. Through 6 machines. 6 machines. The sequences are given below. Sequences are given below. Find the total elapsed time. Find total elapsed time. Time for both the jobs. For both the jobs. For both the jobs. So, and also specify the job that should be done first. That should be done first. So it's a question problem I'm solving here. So you have here job 1 and machine sequence given here. Machine sequence and also the processing time in hours. Okay, yeah, machine sequence CAE. FTB, FD, sequence given for job 1, 2, 3, 4, 6, 2, 3, 4, 5, 6, 1 processing time. Similarly, you have job 2, machine sequence and time in hours. So BAE, FCD, Five, 3, 2, 3. Okay, this is the 12 marks problem. This is the question problem last times. Okay. 2 jobs processing through 6 machines. The sequences are given below. Find the total elapsed time for both the jobs. And also specify the job that should be done first. You have job 1, machine sequence given, that is CAEFDB, and the processing time also given 2, 3, 4, 5, 6, 1. Machine sequence given for job 2, that is BAEFCD, and the job 2 time, that is 3, 2, 5, 3, 2, 3. So these are things given. So simple problem. Okay. So you have to plot the graph now. Okay. So before that, have you taken this problem? Have you taken? Hello?
Noting down, sir.
Yeah, done, no? Okay, done. So before that, what I'm going to do is, I'm going to show you one more problem. That is, so this is already taken, already shared also in the group also have shared. Okay. Also shown, already solved, this problem is solved. Okay. Next, 2 jobs. Okay. Okay, keep the question per problem aside now. You take this problem now. I want to show the exact graph here. Because I'm not going to draw here, already drawn this problem. You keep the problem with you now. It may come for either OBA or CI, we don't know. Okay, I'm not going to solve this problem. Just you take this problem now. 2 jobs are to be performed on 5 machines A, B, C, D, and D. Processing time are given below. Processing time are given below. So you have to find, okay, find total time needed to complete. Find the total time needed to complete both the jobs, and also the sequence you have to find out, and also sequence. Yeah, these things you have to find out, like just the previous problem only. So take the job now. That is job one. Sorry, job one. You have sequence A, B, C, D, E. Time given 3, 4, 2, and 6, 2. Job two. Sequence given, that is B, C, A, D, E. Time, percent time given in hours 5, 4, 3, 2, 6. Done? Have you taken?
Yes, sir.
So there or not, I don't know. I'm answering. Anyway, it's very important to understand the
Yes, sir.
problem.
Taken
You
down.
can't solve on your own. Okay. Now, see here, it's a perfect graph shown here for the problem, given problem. Is shown perfectly. You please draw this problem. You draw this graph indicating all the sequences. It is A, B, C, D, E, along with the B, C, A, D, E. Mark the question times of job 1, job 2 on X, Y, X respectively. Draw the rectangular blocks by pairing the same machines as shown in the following figure. You have to pair the job machines. Okay, that is same A from job 1, A from job 2, like this. You have to pair it and make the boxes. You take your own time and do. Don't be in a hurry to complete it. Okay, mark all the sequences now. Yes, for job 1, job 2, and job 1. Mark all the distance. You just don't have to follow same. You can follow even the method what I told. The class is ಮಾಡ್ತಿರೋದು ನಿಮಿಷ ಕ್ಲಾಸ್ ಒಂದು ನಿಮಿಷ ಕ್ಲಾಸ್ ಇದೆ ಮಾಡ್ತೀನಿ ನಾನು ಮಾಡ್ತೀನಿ ಅರ್ಧ ಗಂಟೆ Okay, you just mark these two, job 1, job 2. Then corresponding boxes you make, okay? This A, B, C, D and E. Make all the boxes. And also mark like this, so to understand mistake previously, the same thing you mark it. You make a box. So to understand the exactly box there, sorry. You mark like this. So mark all A, B, C, D, E. That is by pairing the machines from here D and this here D like this. Okay. Pair it. And afterwards from this point, you exactly draw 45 degree line here. So from here to here. See, from here you can go, you can also go here also. And up to here you can go. And from here you can go. You can go here, of course, no problem. But what happens here, if you go like this here, unnecessarily this job to become idle, this position become idle. So you are trying to avoid. And here, if you want to do like this, from here you have to do, means you are making unnecessarily job on idle. So you are going to get more idle time if you want to draw like this. Okay, so you have to avoid this one, but avoid. That's why from here, this point, it's very crucial point here. So either you can go here. If you go here, then you have to draw up to here. Then you have to draw like this. Then you have to draw like this. But here, if you want to draw like this, only this position becomes idle time. This one, switch on. Very important. You have to make sure that you should avoid as far as possible this time and this time also should avoid, because this indicates that job 1 idle. Okay, job 1 idle. This indicates that job 2 idle. So we should avoid as far as possible these straight line and these lines. Always should go for only 45 degree lines. Okay, that's why we are drawn from here. Very important crucial point. Even here anyway, you can't cross it. You can take here only. There's no option here. You are going here. But here also you have to draw 45 degree only. But only from here, either you can go here or you can go here. This is why very important. Basically, you have to make sure that you're going to make very less idle time. Okay, you should avoid more idle time. Okay, understood now? You understood? You are still drawing?
Still drawing, sir.
Yeah, okay. You do it, yeah, Aram said. Because so you can complete this portion today. I thought of closing this graphical solution.
Done with the diagram, sir.
Okay. Now, how to find the processing time? This is the total processing time. So from here to here, the total time processing time of job 1 up to here, and check out how much idle time of job 1 now. It is, I think, here 2 plus 1, I think, I don't know exactly. This idle time for job. So here also, it's here. Job 1 is idle here also and here also. These are the 2 idle time for job 1. So total processing time plus this idle time becomes the total elapsed time for job 1. Job 2 total processing time plus here, when you want to meet here, so they have to become idle here. So this much of job idle time. So totally you are going to get some amount. Okay, here. Starting from origin O, move through the particular line until a point mark finish is obtained. The elapsed time can be calculated by adding the idle time for either job to the processing time for the job. In this illustration, idle time for job 1 is 5, 3 plus 2 hours. So total elapsed time becomes processing time of job 1 plus idle time of job 1. That is totally equal to 22. That is 17 total initially plus 5 idle time, total 22 hours. Likewise for job 2, idle time is 2 hours. So total elapsed time is processing time, that is 5 plus 4 plus 3 plus 2 plus 6 plus 2 idle time become 22 hours. Okay, so 22 and 22. You can take this problem, so you can take. Okay, done. Okay, this problem, back to this problem now. Same as the previous 2 problems. So I don't want to do this problem once again because it's repetitive in nature. You are drawing that graph along with the given sequence CAFDB, and even job 2 you are going to draw, and you are drawing the 45-degree line, so finding the total elapsed time. And similarly drawing the bar chart as per the graph, and finding which job should be done first. Okay. So this problem is, I'm going to take now next chapter, the same unit. Here, some more a small chapter there in unit number 4. Unit 4. So you have 2 things. One is sequencing, and second thing is that's queuing theory. Okay, queuing theory. So this usually for 12 marks is for 8 marks question, or sometimes 14 plus 6 likewise. Okay, so very simple chapter, this queuing theory. So just I want to give the introduction about this chapter and stop. Tomorrow I'm going to take the problems in queuing theory. Okay. So first of all, understand why that the queuing problem arises. Why this waiting comes into picture? Why the queue forms? Can anyone tell? Why that queuing starts? What reason behind the queuing or waiting lines?
Because of a slow production line,
Because of slow production line.
unavailability of workers,
Yeah. Of course, you can say it. You can say it. There is a demand. Too much demand is there. Okay, too much demand is there. Yeah, too much demand. Too much. Sorry. Yeah, too much demand is there. Okay, demand on the facilities. But inadequate service facilities. Okay. So you have too much demand here. Okay, demand is there, but meantime you don't have sufficient facility to serve it. It's the one reason you can say it. Okay. Second reason. Okay. Say for example here, like sometimes there is a less demand. Sometimes you can say it too less demand. Too much of less demand. There is no demand here. But what happens? This leads to the idleness of service facilities. Okay. For example, you might have seen that in what do you call it, some toll gate and all. Okay, you can say it, tolls. Okay, during Corona time, okay, that is COVID, some Corona this time, no. That time, in fact, what happens here, because though no vehicles, okay, no vehicles, certainly all the service become idle because nobody there, no. So it becomes. So sometimes also it happens that there is no demand, but all the service become the idle. This also leads to the waiting. So here, vehicles are waiting here because you have more vehicles, but there is no much service centers available in the toll. Sometimes what happens here, you have no demand, okay, so no vehicles coming in, but that leads to idleness of the service facilities. So both are the reason for queuing theory. Okay. So here people are waiting to get served. People are waiting for service, but here people are waiting to get service. Okay. That's why there are the two reasons for queuing theory. Okay. These are reason for queuing. Okay, or waiting lines. Okay. Now here there are some elements here. Okay, elements in queuing system. There are elements of a queuing system. Okay, so there are totally 7 elements. Okay. So one, of course, that is arrival distribution. Okay. Arrival distribution. Sorry, distribution. Okay. That is what is about arrival distribution? It is you can set arrival rate. Okay, arrival rate. How frequently the things are coming there to get served. Okay, arrival rate. You would have seen that in the queues, maybe in a petrol bank or railway overbridge, railway track, railway gates and all, or even in many times in a toll and all. So this is not always equal. Okay, there's going to be so much of variation in arrival rate. Okay, so that you can say it inter arrival. We can say it. Okay, so here what happens here? So basically we are finding here how many customers are coming here, number of customers arriving, customers arriving to get served. Okay, that is what arriving. Arriving to get served. That's what one is called as the arrival distribution, one of the important element of queuing theory. Second element, that is departure distribution. Okay, that is service. Okay, that is departure. How fastly they get serviced. Okay, that is departure distribution. It's all very important in the queuing theory. Okay, that is service. How much each customer going to take time to get served. Okay, and the third is service channels. Okay, service channels. How many channels are there to get queue service? Okay, channels very important here. More channels, you're going to get very quick service. Less channels takes more amount of time for getting served. And the fourth one, service discipline. Okay, service discipline. Okay, what order they're going to follow? Okay, it is what order they're going to. It is priority. Okay, you can say it here. The order of service, you can say it. Service discipline, nothing but you can say it. Order of service. Whether they're going to serve based upon some priority, okay, priority, or based upon randomly sometimes, randomly, okay. It also matters sometimes, okay. Probably you might have seen that ladies first are old age people first, and then others are sometimes randomly. They don't even they want to make sure that all should come in same queue. Okay, there is no discrimination of any male, female, or old or new and all. So very important here. One more discipline. What are they going to get served? And fifth one, maximum number of customers. Okay, very important here. Maximum number of customers. Capacity. Maximum number of customers. It's very important element in the queuing theory because we're going to decide the number of services required here. You can number of customers around the study. I think we can say the capacity of the system. Okay, capacity of the system. That's very important. And sixth element, you can say that is calling source or population. Calling source or population. Okay, population. It's very important. But I've seen that, for example, let us say in a toll, same example, take toll here. That is the type of vehicles can have very important here. For example, let us say if all our cars having a fast tag, things will move fastly. There sometimes some trucks come in between. So much of so they are not going to pay through tax, or the rates are also different. And suddenly sometimes you might have seen that based upon the tonnage capacity they're going to charge. So they're going to be always fighting between that service stations along with these people, tall people and the trucks and all. So the bargaining for the price and all. So this is very important here. Where the people come from? It is population. What type of population? If it is same equal type of vehicles, then everything will be smooth. And lastly, customers' behavior. Okay, customers' behavior is very important here. Okay, customers' behavior. Okay, behavior. Because here, what happens here? But I've seen that customers are going to change so frequently. It is shifting from this queue there. So then suddenly these people come here and they're going to go here. And they're going to come here because they think that there are less people are there here. They're going to change it. Sometimes they don't want to go to queue also. They want to return back by seeing the queue. You might have seen that particularly in case of movie theater, if they find lots of queue there, they don't want to go. Okay, so these things are there here. These things are there here today. So they are the 7 elements of queuing theory. Okay, that is order distribution, device distribution, service channels, service discipline, maximum number of customers, nothing but you can say the capacity, along with the calling service source, nothing but the population, where the people come from. It is the source, you can say it, basically the source of people come from. Okay, source very important, and the customers' behavior. Okay, how they behave, whether they go with move to other queue, or sometimes not entering the queue only. Okay, those are the customer behavior, also very important. These are the some elements of queuing system. Okay. Next here, I want to write one here, one notation here. It is Inda's notation for representing queuing models. Queuing models. A arrow distribution. This is basically representing the queue model. Okay. A arrow distribution. B service distribution. And C number of channels. Number of service stations. And D represents self-discipline. Service discipline. That is, you can say it FCFS, first come first serve, or last come first serve. Okay, first because they're going to have some their own discipline service, and E is equals to capacity of the system, number of pattern allowed in the system, and F is equals to calling source. Okay, where the people come from. Source. Okay, that's all. That's about how we're going to represent the queuing models. So it's called as Kenda's notation for representing the queuing model. A/B/C is to D/E/F. These things are given here. Okay, that's all. Next year, just I want to draw the formula only today, and tomorrow I'm going to solve the problems. Traffic intensity is given by lambda by mu. Lambda by mu. Also called as utilization factor. Utilization factor. Okay. Later we can say at capacity of the service station utilized. Okay. For example, I'll tell you how to find out. For example, if customers arrives at the rate of the rate of 9 customers per hour, 9 per hour, and service rate is 10 per hour. 10 per hour. Then traffic intensity is equals to lambda by mu. Okay, that is, you can say arrival rate by service rate. That is equals to 9 by 10. 9 by 10. That is equal to 90%. Okay, that's how we are finding the traffic intensity. Okay, lambda by mu. Lambda basically arrival rate, mu is the service rate. Okay, that's how we are finding the traffic intensity. Second one, every length of Q. How to find the average length of Q. Equals to 1 by LQ. I think we're going to consider the Q length, you can say it. Okay. Q length LQ is equals to lambda by mu into lambda by mu minus lambda. Okay. I think what I'm saying. Hello. I'll take class today. At 12 o'clock. Okay, no? Hello. Yeah. I'll take class today. At 12 o'clock. Good morning. ಗೊತ್ತಾಯ್ತು ನಾನು ಕ್ಲಾಸ್ ಹೋಗ್ತೀನಿ 12 o'clock. ಓಕೆನಾ? ಹಲೋ. ಹಲೋ. ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಕ್ಲಾಸ್ ಓದಿರೋದಾ? ಕ್ಲಾಸ್ ತೊಗೊಳ್ತೀನಿ. ಓಕೆನಾ? 12 o'clock. SCM, supply chain management. Supply chain management. I will take today. Okay. ನಾನು ಕ್ಲಾಸ್ ಇದೆ, ಕ್ಲಾಸ್ ಮಾಡ್ತೀನಿ. ಆನ್ ಮಾಡಲಾ? ಅರ್ಧ ಗಂಟೆ ಬಿಟ್ಟು 12 o'clock ಮಾಡ್ತೀನಿ. You have to remember the formula only, rather than the units in the system. system is given by LS. Nothing but you can say the system length. System length is given by lambda by mu minus lambda. Fourth one. Expected length of non-empty queue. Non-empty queue is equal to LB. So LB is equals to mu by mu minus lambda. Fifth one. Average waiting time of arrival. Waiting time of arrival. Third also condenser. Average waiting time in queue. Average waiting time in queue. Waiting time in queue is given by lambda by mu into mu minus lambda. These formula you have to remember. That's all. There is no way to explain because we are not going to derivation and all. Okay, so you have to remember the formula. Okay, you may ask you to find out the Q length. Remember, all the formula based upon only two values: lambda, the arrival rate, and the mu, service rate only. These two are very important. So, for example, here, let's say second, we are finding the average length of Q, that is the LQ. So, given by lambda by mu into lambda by mu minus lambda. Suppose if you want to find out the average number of units in the system length, the LS, lambda by mu minus lambda. If you want to find out the non-empty queue, that is LB, mu by mu minus lambda. If you want to find out the average waiting time of arrival, nothing but the average waiting time in queue is given by lambda by mu into lambda minus mu. Sorry, lambda by mu into mu minus lambda. Okay, you have to remember this formula only. And only one formula is there, one more formula is there. I'll write and I'll stop today. The sixth one, that is average time in arrival spends in the system. Means they are already entered in the queue, they are waiting for the getting served. Okay, the system, nothing but you can say WS is given by 1 by mu minus lambda. And the last one, seventh one. Yeah, that's all. Okay, that's all. Right. So you have to remember only these 6 formula. That's all. So the questions will be asked only based upon this formula only. Okay, this we can say it is a formula based chapter. Okay, that's all for today class. So we'll see you tomorrow at 10 o'clock.
Thank you, sir.
Okay, so tomorrow I'm going to take the same queuing theory and so completing unit 4. So left with unit 2 and 3. I think other division students, Burra Kuka told that he's taken unit 3. So I think next week I'll start unit 3 only. That is assignment and transportation. Okay. So anyway, I'm completing unit 4 now by tomorrow. Okay, that's all. See you tomorrow.
Okay, sir.